Hey everybody, we're going to go deeper into the air conditioning system now. We're going to kind of do a component of operation and some of the service aspects to it. But remember, we're going to break it down even farther. So we're just going to go over generally, try to get you to understand which components go with which type of system, like I've been talking in class for the last few days. So let's go ahead and get started. We'll open up the share like always. And we'll be off and running to the races, as they say. Okay, so when we start talking about air conditioning system, of course, you'll remember this one. This is going to be what I want you to memorize for your exams, because you'll see this come up quite a few times. Depending on where you want to start, we know where the gas is and in what state, but then we need to understand which components do what and how they do it. So we're going to go ahead and start with the condenser, where the action diagram talks about it. So there's the condenser that's, and I have a picture right here of where the condenser is located. So you'll have the radiator here, and then the condenser will be up front. Now, some of the early Dodges actually had a split. So where half of the radiator would be in one side and the condenser would be on the other side. And you'll also have fans involved in it. So this shows a mechanical fan, but more than likely, especially when you're working on the new equipment, you're going to have an electric fan. And some systems, believe it or not, they actually had both. And I'll get into that in a little bit. But you're going to have some kind of exchange of the heat. So we need to have a good operating fan. If you don't have a good operating fan, you can see high side pressures like that. So, and you could even go beyond that too. So this is a picture of this is actually a two-fan system on a Dodge truck that actually has an electric fan. And then it has a mechanical fan too on top of it. This, to me, this would cancel some things out, but I do understand how partially how it works. We want to make sure enough airflow goes across. If it doesn't have enough airflow, like I said before, you can see some of those excited or elevated pressures on the high side. All right, so there's different types of actually evaporators. There's some that are what they call a tube and fin condenser. I'm sorry, condenser. We haven't gotten to evaporators yet. So there's a series of tubes going around, and the fins are what help dissipate the heat. Then you get a little bit of airflow going across it, and it really helps. This is why I was, and we'll go deeper into it when we get into the condenser section of this class. This series of the air conditioning system, but there's also a flattened tube, and sometimes you'll find that there will be an oval tube also. So it depends on what kind of system and what the manufacturer put in. Sometimes you can actually upgrade from a round tube to a flattened tube. It just really depends on the year, make, and model. Like that too. So this is where I want to really get into and I'll go deeper into when we get in just into condensers, a little segment on that. But you can see how small those tubes are. And one of the things I've seen happen is it's not, we've got a pencil right there right now. You can see the pencil would fit in and not go all the way in already. And when you have debris that actually goes through the system, it will actually start plugging those little channels up, those little, the little flattened tubes or the round tubes as go around too. So this is where, if you get a compressor that explodes or you get a little bit of debris going floating around inside of it, a lot of times you can't just flush the systems out. There are different types of, like I said before, they have the serpentine type, which, normally on your tube type ones, and then you have a parallel type ones, usually your flattened channels and stuff like that. So I put a couple pictures of what one would look like in real life versus just a drawing of it. And here's your regular parallel type ones too. Now, to put things in kind of context, going from where it goes into the condenser. You remember we're taking a high pressure gas, okay, that came out of the compressor, and then we're going to actually go through the process of condensing. That's what the condenser does. We're going to take the heat away, which is going to start turning it into a liquid. So you can see just by this gas volume goes from entering in, and then when it's goes out, it's like a 1,000 times the volume when it goes into leaving out as a liquid. So some condensers, and I'll go deeper into it, are designed to kind of accommodate that. So we'll get deeper into that as we go, just on the condenser part. All right. This shows the condenser going across. So this is a dual condenser, is a condenser where the refrigerant flows from the condenser portion through the modular type system portion. And then, instead of having a receiver dryer like we've seen before, it actually has a desiccant bag. So if you take that little plug off the bottom here, you can actually pull the desiccant out and actually change it out. Now, be very careful. If you've seen a lot of debris inside of this, you may want to change that condenser, because again, those channels are pretty small, the little tubes. So depending on which one you have, but it could be fairly small. All right, and then our expansion devices, our TXVs. I'm just going to start off with the typical expansion valve, and it is actually attached a lot of times to the evaporator, and then it has some sensing bulbs to it. So you'll actually see the tubes here. One's actually on the line, and then we have this tube here, where sometimes we actually will have an actual secondary tube going right into the fins, so we can actually modulate that actual refrigerant from coming in. There are different types of types of systems. What they use is a sensing bulb on your TXVs, and then it can actually open and close the valve a little bit finer versus just a fixed orifice type of system. So you can see how the passage changes as that bulb moves. So we had it actually not opened. Now it actually closes, it allows it to flow through. But here, when the diaphragm, opens up, it actually closes it off, so we don't have as much refrigerant coming through. So internally, it kind of equalizes out on this particular one. So you can see this one actually has this type of system. This has another tube type system on it. So it actually, like I said before in the other one, we have an extra tube to do some more sensing on it. So it can actually get it a little bit finer as we go along. And then we have the ones like the expansion blocks that are out there. So we'll actually have a different type of setup where we'll actually use it channeling in and out through this actually block. And I'll show you a picture of a block in just a little bit here. This is a kind of a slot cut in the ball, so that actually allows it to seal inside the expansion valve, permitting the refrigerant and the oil to pass through it at all times, even with the valve actually closed. So it will cause it to still let it bleed just a little bit across it. And then we go into our expansion blocks, or sometimes they call them the H blocks. These systems actually are used quite a bit. I think pretty much all of our cars that we have right now in the shop have the expansion blocks to them, which, you can see that they work very well. So again, it's similar to a TXV, but now we're actually using that actually control off the diaphragm on the top there. So, Chrysler minivans were famous for it, but now we're starting to see it in regular other cars as we've been in there. So again, we've got quite a few vehicles out in the shop, and I would say all of them have the expansion block right now, or the H block. The other system is the fixed orifice system. This is kind of a typical one. One of the things I wanted to point out that there are different colors, and depending on the make and model, they might even upgrade them later. So it's very important that you look at technical service bulletins to make sure it's they say, okay, you need to put a yellow with a green tracer on it or something like that. So be careful about just substituting the wrong color in. You could cause problems by doing that. I've seen some texts that were actually just putting only white in there, where they were called for a different orifice size. So that actually did not work. And sometimes the fixed orifice tube is a little bit different shape too. All right. So make sure you put the right one in. There's an O-ring, and it actually restricts the flow. So you've got it going in. I'm sorry, you got it coming from the actual condenser going to the evaporator right here. As you can see, there's a screen here, and there's another filter screen on this side. There are down in close to most of the times. I did find one time it was really, I was looking everywhere for it, and I found it was actually in the condenser, right off the tube coming out of the condenser. But they will generally be, if you do have a fixed orifice tube system, they will be in the evaporator. So the inlet to the evaporator, as it goes across, that's where you'll find it. There is another type of fixed orifice tube. This is what they call a variable orifice valve system. It uses kind of a bimetal coil spring to sense the temperature. And depending on if it's a high temperature, like it's a little bit warmer, it will cause the coil to expand, and it can actually change and expand and contract depending on what kind of temperature it is. So it can actually modify that actual refrigerant flow, almost like an expansion block or an expansion valve does. But these are not new. They've been out there for quite a few years. The other one, that's the newest one, is this is an electronic orifice where it actually, the computer or the PCM or the body control computer will actually kind of open and close the valve and modulate the valve that way. So this is fairly new. It's been out there for a few years, but this is an electronic orifice tube that actually has a solenoid in it to actually change it and modulate it. All right, so the evaporator is part of the low pressure side of the actual refrigerant cycle, and is used to transfer the heat from the inside of the vehicle to the refrigerant flow through the actual internal tubes. So we're taking the evaporator, and instead of pushing out the heat, we're actually absorbing heat. That refrigerant is going to be that transfer unit. So we're showing the expansion valve system here, and it's going through and absorbing the heat, and it's going through, boom. So remember, it's a low pressure liquid coming out of the expansion valve, and as it goes through, it causes the refrigerant to boil. And as it boils, it actually picks up some of that heat by the boiling process, and it turns it into a gas. And as it goes out, it's a low pressure gas. And this is kind of showing your little your service valve, or they call it a tap here, but this is where your service valve is at, so you can measure the pressures, and then it goes back into the compressor and starts the whole process over again. Just like the condenser, we do have tube and fin type evaporators, or we have a plate type evaporator. Each have large contact areas for the heat to be absorbed, and then it will actually go in contact with the refrigerant and take and transfer that heat out. Just showing you location of the evaporator in the actual case, where we'll get deeper into when we start getting into airflow of how that all plays out with the evaporator and the actual heater core, how it lays in there, and how the air goes through to actually change the temperatures inside the vehicle. It shows the blower motor, it shows you the suction line, and also shows you the liquid line. And one of the things I want to point out is water in the system can cause really serious problems. This is why we want to bring it down into the system down when we evacuate it and pull it into a vacuum. We want to bring it down to a low vacuum, somewhere around 29 inch pounds, so we can actually bring it down, boil any kind of moisture, and take some of the moisture out of the receiver dryer too. Remember, the receiver dryer and the accumulator has a desiccant in it, which actually absorbs moisture. And if you start seeing, if you start having moisture problems, you're going to start seeing some icing forming, and maybe even to the point of forming ice, and it gets some blockage going on. You're going to see your pressures really change kind of strangely. You could actually start seeing some pinhole leaks going on, etching going on. You can actually see some rust when you start taking the lines off. Then you know you definitely got a moisture problem in it. Accumulators, they are similar to a receiver dryer, but not exactly the same. They are used on the fixed orifice tube systems, and they have a spot where they can actually have a capture for the oil, and there's a small little hole in the bottom of the screen on it, so it can actually pull some of the oil in. So the coming out from the evaporator, going in, and it actually kind of boils a little bit, and then we're going to actually cause to pull a gas in. So we'll make sure it goes to the compressor, the gas. But if you overcharge the refrigerant, it can actually suck it through that tube and cause it to actually damage the compressor. So you want to be very careful about charges. Receiver dryers. This is a receiver dryer. This is an accumulator right here. You'll actually see where it's going to. I was looking at the next page. I'm sorry, but here's your receiver accumulator, and here are the lines going into this particular one. And then we have a pressure switch. We'll have a pressure switch part coming up with all the electronics. All right, and then we have the receiver dryer, like I was talking about earlier, but now we have the receiver dryer. Some of your receiver dryers will actually have a little sight glass. This is how one of our old R12 systems, that's partially how we actually charge them up. We would actually look for bubbles, and if you've seen a ton of bubbles, then you knew you had a low charge system on it. That doesn't work with the accumulators, but the receiver dryers, sometimes you'll have a sight glass, sometimes you won't, and they have similar stuff inside the actual receiver dryer as you did in the accumulator. But you'll have like a desiccant again to one of the things I want to say about desiccant, you don't want to get them oversaturated with moisture. If they get oversaturated with moisture, they can actually burst, and then you got all these little desiccant beads flowing through your system, and it can really cause havoc of plugging. You could actually, if it gets to the compressor, you start seeing hearing some weird noises going on. And when we get in the compressors, you'll see how it can actually interrupt the reed valves too, as going to. But again, still, we're going to collect a little bit of oil. It's going to suck the refrigerant and keep it the refrigerant as dry as possible. All right. And then our lines, there's some rigid lines, there's some flexible lines. We need flexible lines, especially when it's close to the engine, because the engine is not solid. We have engine mounts that are rubber, or some of them are actually hydraulic with rubber, and they'll actually move. Okay, so they're actually they move just a little bit. I'm over exaggerating right now, but they'll move a little bit. So if we don't have that flexibility, it would kind of rip the lines and break them. So there are some rigid lines where it's close to the actual frame area or the chassis area. But when it comes to where it's into the actual engine where the compressor is mounted, then you're going to see some more flexible lines in it too. And then there's three major hoses. Like I kind of said before, we have different hoses on it. They'll have flexible ones, and then you'll have actual hardline ones. When we get close to the different lines, you definitely have like the discharge lines, liquid line, and the suction lines. And it's just we can have two liquid lines sometimes too. So it just we'll go more over this when we get stored into the lines and the fittings and also the O-rings. And there's different types of lines, which when you're fitting O-rings, you need to know this. They'll be in diameters of the outside diameter, the inside diameter, and when you're fitting O-rings, it's very important you put the right side of the O-rings on. Sometimes they'll say, give me a number 6 O-ring or a number 8 O-ring. This is what they're talking about. And then we have different types of fittings. We actually have fittings that actually have a tapered fitting size to them, where the fitting kind of clamps onto. We also have different types of fittings where they crush differently. So we want to make sure you line up the fittings straight. One thing, I've seen some poor lineups and it cause them to leak, especially on your flare types. If you get them a little kind of cockeyed, they can actually leak. Some of the lines kind of fit right in, and the only way they'll go in, but some of them you can actually get off center just a little bit. And then there's, which was really famous with the Ford products at one time, and I think they still use them, but there's a spring and lock type, which is a quick type connector. They can be kind of a barrier to get off and get on. They actually have a little spring inside that locks it in place. They're double O-ringed to keep from it. And you'll actually find some kits, and I'll get into them, where they actually make them a little more rigid, because with that spring and lock, they can actually move around just a little bit. So here is that O-ring, what I was talking about just a little while ago, and this is showing you an actual one right here. Okay, so 2 O-rings, then we have a cage spring, and I'll show you how they all work when we get more into the lines and stuff. And you'll need some special tools for the you'll need tools anyways, but you'll need special tools for the actual quick connect and disconnect on your spring locks and stuff like that too. So there's a little finger in the plastic tool that actually pulls it off. And then we have O-rings, and when I get into the O-rings, please stay tuned, because it's important that you understand that not all rings work on all systems. You want to make sure you use the correct O-ring for the system you're working on. The R12 systems were a different type of oil, and when you get into the 134AA and also go into the R1234YF, you want to make sure you use the right O-rings so you don't have any degrade of them, and you can start getting some kind of a leak. And then, of course, the early systems really did not have a lot of electronics to it. We'll be going deep into it. We'll start into the actual basics. We're going to go with the old systems, and we're going to build ourselves out as we go along. So you'll see it's a really simple circuit, but you'll see that they've actually changed quite a bit. And then we'll talk about pressure switches. When we start getting into more of the electronics, and I'll talk more about pressure switches and how they assist the system on getting information, okay, and allowing the refrigerant to either a clutch cycling system or having the computer control the clutch. So this is going to be information going in, and there'll be different types. So you can have 2-wire types, 3-wire, 5-wire types out there. And then, of course, you've seen this before. We have, well, you may not have seen this before. I should have put it that way. There, it was a system that was called a suction throttling valve. You still see some of them in the heavy equipment. I don't see them so much in the car, but they were actually used to help keep from the evaporators icing. This was one of the things we had problems with, but as long as you keep things nice and the refrigerant clear, watching your pressures, you probably won't have that much icing going on. And this is showing a dual system. Some of your SUVs and some of your minivans will actually have a separate system in the back. And we're going to go over that also, and how we can actually have 2 different controls, one for the front and one for the rear. And when we start talking more about the electronics on it too. And then one of the things you're going to want to be very cautious of is your lines. When you start taking components apart, make sure you follow procedures. You can actually kink lines when you're trying to refit O-rings or take apart or put things back together. And then if you get a kink in it, then you've got a little bit of restriction. So that's another concern. There are different types of ways of, either you can buy lines or you can make lines. This is a couple of things. I showed you that little kit we had in the shop the other day. So this is an option. Some shops prefer to make their own lines versus buy them straight out from a store. So this is a crimping device. This is, we'll put the crimps in properly. One of the things I'm going to get a little bit deeper into fixed orifice is talk about fixed orifice. Some of the pains you can have with fixed orifice too. Sometimes the fixed orifice, you can actually pull it out with just a needle nose plier, but sometimes you can actually break them in the process. And you may need to have, which I recommend you have, is this special tool. This special tool actually fits over. You can actually twist the fixed orifice just a little bit to actually bring it up a little bit easier. Sometimes you have to put a little bit of the refrigerant oil down in there to actually get the O-rings, because the O-rings, especially when you get the double O-ring rings fixed orifices, they can actually really stick in there after a period of time through the process of heating and cooling. It can actually cause it to actually. What I've done too is I've taken a regular heat gun, some people call it the hair dryer, and go around the surface of the area so the aluminum expands a little bit so you can get it out a little bit easier too. And of course, lastly, I wanted to say again about the different color of O-rings. I got another one here where it shows the different colors. You can have white tops, green bottoms, and you can have all kinds of different types of O-rings. So make sure you put the right O-ring in, because the size can be different. The O-ring sealing can be different. All of it, all the different things can be different on it. So, okay, so this is an overview of the parts and some of the different components. We've talked about the in general about the expansion part of it. We haven't really talked too much about the different section of the parts. Remember, if it's a fixed surface system, it's going to have an accumulator. If it's an expansion valve system, it's going to have a receiver drive. And we'll break down some of the different parts a little bit farther, and then we'll start talking about the repairing part of it too, and diagnosing it. Don't forget that part. All right. We will talk to you soon. If you like this and and it was beneficial to you, please like and just actually subscribe. And I will definitely be putting up more videos as the weeks go on. All right. Talk to you soon. Bye for now.